Hello and good morning, or good afternoon, or good evening, depending on where you're dialing in from. My name is Michael Cook, and I'm the Design Outreach Project Lead for the India Mark II and AfriDev Handpump Upgrade Project, also the R&D Partnerships Director for Design Outreach. So I'm hoping after enjoying the last two talks from Richard and Beatrice that you are convinced of the importance of hand pumps, that you're convinced of the need for greater reliability of these public domain hand pumps, and also that hand pumps will be needed for a very, very long time. And like Richard said, even though technologies like solar pumps are increasing, which they very well should be, we don't want to leave behind any of the dear people who are still relying on hand pumps. And data shows that hand pumps are still an important part of the toolkit, even when installed alongside motorized solutions. So now I'd like to give you a project overview, and then we'll follow that up with a sneak preview into the results from our hand pump questionnaire. So we understand that improving hand pump reliability is a monumental task. And not only in improving the design, which is necessary, but also the supply chain, quality control, and then adopting whatever improvements have been developed. And because of that, Design Outreach has partnered with Neil Consulting Engineers from the UK, Sandy Pollock and Paul Dawson, and we've embarked on what we think is a 5-year journey to improve hand pump reliability. And even though this is a big challenge, we believe that by partnering with people who are passionate about solving this problem, like yourselves, and walking arm in arm together in the same direction, we can improve and move the needle in a positive direction. So you might wonder, why Design Outreach, why Neil Consulting Engineers? Well, since 2010, Design Outreach has been immersed in the persistent issues of public domain hand pumps. We've conducted research, attended conferences, we're part of the RWSN Stop the Rot Action Group, and we also work with our field partners. And many of these folks complement AfriDev and India Mark II in their portfolio, along with the DO Life Pump. And we've also visited many of the communities in the 10 African countries where DO works. Also, we've, as a team, grown in the past 4 years to 30 plus full and part-time employees, and we have an extensive network of volunteer engineers and designers, many of whom are experts in their respective field. And we've collaborated with industry and academic partners and field implementing partners. So this puts us in a good place to work together with all of you to move toward a common goal. Now, Neil Consulting Engineers, now called Polo Designs, they've carried out pro bono design and development work in this appropriate technology space with hand pumps and wind pumps since 1984. At one point, they were manufacturing wind pumps in country in more than 10 countries. And they've also developed a deep well hand pump. Now you might wonder, how is this project funded? Well, it's not funded by some big grant that when it disappears, the work comes to a screeching halt. Rather, it's funded from a private donor base of individuals, churches, and organizations who support the ongoing work of Design Outreach. And it is running in parallel with another project that Sandy and Paul are working on with WaterAid, which is focusing on India Mark II and solving the corrosion issues with the riser pipes. Now I'd like to draw your attention to our core team at the top right. You've already heard Beatrice's talk. So we have Beatrice and Dixon in our Malawi field office, and Chazela is in Zambia, and they are our core team from Africa. Then we have, of course, Paul and Sandy from the UK, and then Abe and Rick and myself from the US. Now we've expanded beyond the core team, and we have a very extensive advisor team. And I won't read all the names, but you can see we have representation from Uganda, Malawi, Zambia, US, UK, Switzerland, and so we have quite an extensive, very deeply experienced advisor team to work with. And on the left here, you can see the partnerships that I had mentioned before. RWSN Stop the Rot Action Group, also working relationships with universities and hand pump experts. So even though the studies on specific technical failure modes of hand pumps is limited, there are already known failure modes from anecdotal evidence and from recent studies. And I'd like to highlight this study from Messiah University that highlighted multiple failure modes of hand pumps. And there also have been various attempts by individual organizations, universities, and inventors over the past several decades to improve these pumps. And we say a huge thank you to each person, each organization that has worked on this challenge. So unfortunately, there have been many efforts scattered around the globe, and they haven't gained traction or widespread adoption. So we hope to change that, but by combining efforts with all of these organizations and working together toward this common goal. So the design challenge for this project is to firstly improve the repair interval on fast wearing parts from 6 months to an average of 2 to 3 years. Also ensure that expensive parts that require major repairs last 10 plus years. In some cases, they should last 20 years. Also eliminate corrosion from pipes and excessive lead and iron from water. And then advocate for the update of the IM2 and AFRIDEV standards. Although there have been many studies done over the years, we wanted to gain a fresh perspective from the field. So we recently launched a hand pump reliability questionnaire, and many thanks to those on this webinar who have already responded. We really appreciate that. Our goal of this questionnaire is to get a better understanding of the failure modes and what specific hand pump components are contributing to early failure, and also to set up project priorities, and we really appreciate your help. So I'd like to here soon show you a sneak preview of the data, the initial data which we've had so far, which does show early failure of certain components. I'd like to draw attention that we have heard from 26 different countries, which is phenomenal. But I'd also like to draw attention to the fact that most of the responses are from Malawi and Zambia, where we do have design outreach team members who have been expediting the questionnaire responses. So that means we're skewed heavily toward AFRIDEV, and we really want to get more responses, not only for India Mark II and III, but from other countries that use AFRIDEV as well. So we really would like your help for that. Please keep in mind that this data is limited in response quantity and geographic location, as you can see. But we did want to show you this early data, which does reveal some surprising results. Well, so far we've received over 200 responses to the hand pump questionnaire. And from the results compiled so far, we can see that 35% are pump mechanics, 31% are government officers, 17% are NGO officers, 16% are considered other, and then 1% have a combined role of pump mechanic and government officer. Then we ask the question, do you agree that hand pumps and reliability will be important for some years in the future? Interestingly enough, the results from our questionnaire correlate very well with Richard's talk about the need for hand pumps long into the future, even though newer technologies are ramping up. So the average view is that we're going to need them for over 20 years, and 31% of respondents believe hand pumps will be needed for 50 years in the future. So on this slide, you can see that with the data that we've compiled so far, we have 133 responses from AFRIDEV and 36 related to India Mark II and III. And you can see the average pump depth is very similar, 38 meters for India Mark II and III and 35.8 on AFRIDEV. And we do want to get more responses, especially on India Mark II and III, so we can have a statistically significant data and be able to really have a clear picture of what is going on in the field. So here is the first slide that shows years to failure for certain um, components. Now, we'd like to have shown pictures on here. Most of you are familiar with these terms. If you are not, I would invite you to go to Dr. Kirsten Danner's Stop the Rot Report 3 and go to page 6 and 7 where it has the drawing, the assembly drawing schematic for both India Mark II and Aphrodite, and it clearly marks out these components. So you can see here we have riser pipe breakage in 5 and 4 years. Those that are highlighted in red shows that we believe that these should be improved. Leakage in 4 years for each one, and then pump rod breakage in 5 years and 4 years. So, these are very expensive repairs. This is capital expense, and it was a bit surprising that Aphrodite showed that it had riser pipes failing this soon, since they're PVC. Now the next page here of components, years to failure. Bucket seals, 4 years on India Mark II and III, which is very respectable. Now look at Aphrodite. The respondents so far show that those bucket seals are failing in 1.2 years. This is wearing out too quickly. And in fact, we've heard anecdotal feedback that some are wearing out much faster than that. Also, the cylinder liners, 5 years to failure. That's a very expensive repair. This is capital expense. Now we're looking at handle pivot bushings or bearings or bushings. On Aphrodite, those are failing at 1.4 years according to our responses. That's very quick. That's a very quick failure, and it does provide an opportunity for design improvement. Okay, on this slide, we show handle weld fracture, 9 and 7 years for India Mark II and Aphrodite. Nuts and bolts loose or missing, 4 years for each. But look at what stands out on this slide. Pump stand flange fracture, 11 years for India Mark II, 6 years for Aphrodite. Now we were a little surprised because we've heard that the issue was more prominent on India Mark II, but the survey shows Aphrodite is actually worse for pump stand flange fracture. Now this is very expensive work, as you know. This is like civil engineering work where you break up the concrete to reinstall pump base. So these really should last much longer. This hand pump failure mode data that we've just discussed, with average years to failure for each component, even though it's preliminary data, it certainly indicates there's room for improvement on multiple components. This initial data, along with previous studies by other individuals and organizations, shows the need for design improvements as well as improvements with the supply chain and quality control of hand pumps and their components. However, we need more data, and we need your help to get that data. Even though this questionnaire so far, with a little over 200 responses, and the average person representing about 100 pumps, that means this questionnaire represents around 20,000 hand pumps. And yes, even though that seems significant, keep in mind that most of these results come from 2 countries. Not only that, we only have 36 responses that were specifically India Mark II and III. So we need to get more data to have statistical significance with our decision making. And if you think about it, there are countries like India, for example, that have millions of India Mark II hand pumps. If you have a contact in India or other countries, please reach out and share the news and cut and paste the link that's attached to this webinar from the list of useful links and send them to your colleagues. And thank you in advance for your support. Also, not only would we like more India Mark II responses, but we would love to have representation from other countries that use the AfriDev hand pump as well, that are currently underrepresented in our study. This is a monumental challenge to improve hand pump reliability. It's a lot of hard work, but we believe if we walk together and we pull together in the same direction, with your help, it is possible to make an improvement. People that rely on these public domain hand pumps deserve better, and better can be achieved with your help. Also, I wanted to let you know that although I'm not able to attend this presentation in person due to a previous obligation, my colleagues Abe Wright and Sandy Pollock are planning to be on the call in person to respond to your questions regarding these survey results. Thank you very, very much for collaborating with us on this hand pump improvement project. And I hope you have a wonderful day.